this is Roberto and this is the HVAC is my channel. Today we're going to be talking about ASHRAE 62.2 2010 and how we apply intermittent ventilation on it. All right, so let's get into it. All right, so for this example we're going to take into account a house. See, so in other words, we're calculating the fresh air for a house. So that would mean residential. Whenever we're talking about houses, we're saying residential. And the house has 1862 square feet. All right. And the number of bedrooms, is 3. There we go. Equals 3. 2 bedrooms. So in other words, in order to calculate the fresh air required, fresh air, they call it also outside air, and then they call it also like a ventilation. Let's put ventilation airflow rate too. Let's put ventilation airflow rate. Okay. Airflow rate. All right, so they're all the same. Let's see. So in order to calculate the fresh air, outside air, or ventilation airflow rate, we only need two inputs, the square feet and the number of bedrooms. Okay, so in order to calculate that, we have the standard ASHRAE 62.2, and that is 2010. And also I want to mention that there is also the ASHRAE 62.2 2013, 2016, in which they require more CFM in order to comply for fresh air. All right, so let's calculate this very quickly. So the formula for ASHRAE for fresh air indicates the following. Fresh air is going to be equal to the following. So this was explained in another video. So 0.01 times square feet. The square feet is 1862, and then plus 7.5 number of bedrooms. That's going to be 3 plus 1. And that's going to give me a total number of 49. So I need 49 CFM of fresh air for this house based on this square feet and 3 bedrooms. Or also you can go to the table. Let's put in here fresh air, and that was explained in another video. So the fresh air is going to be, let's go to the table. So in other words, for this standard ASHRAE 62.2 2010, you have two options of calculating the fresh air requirement. You can either use the formula or you can go to the table. So the table is right here, and 1862 is within this range. See, floor area in square feet. And then the number of bedrooms are 3. So 2 to 3 bedrooms. We do the intersection and we obtain 60. Okay, so now we're going to put in here 60 CFM. 60 CFM. All right. So now you might be wondering, which one are we going to take? We have two fresh airs. Fresh air number 1 is from the formula, and fresh air number 2 is from the table, or they call it prescriptive table. All right. So actually, the prescriptive table allows you, it's a higher number, which is pretty much like a buffer, or it gives you a safety net. So it's going to be better if we consider this 60 CFM. So this would be more precise, and this would be more applicable. So we're going to be safe providing more CFM of outside air ventilation. So we're going to go with this, with the table. So 60 CFM. But these two calculations based on the formula and the table are for continuous ventilation. Continuous. So that means that this fan is going to be running 24/7. And usually what manufacturers do is they utilize the concept of intermittent ventilation. All right, so for that we're going to go to the following. That's what this video is about. Now we're going to take into account the intermittent ventilation. So let's put in here intermittent ventilation. Intermittent ventilation. So for intermittent ventilation, what we need to consider is that the fan, we call it EF, which is pretty much exhaust fan, and the intermittent ventilation pretty much is like the fan is going to be on and off. And two important points to consider in intermittent ventilation. See, I'm making this so it could look nicer. There we go. So two important factors for intermittent ventilation to consider is the following, So the table on top, this figure on top, is coming from the Energy Star certified homes, and certified homes version 3.1. So in this form, it indicates like the ventilation airflow rate required by 62.2 for a continuous ventilation. That would be from the table, and that's going to be 60. Some other programs like RightSoft, they would give you from the formula. So if you're utilizing RightSoft, you're going to have this populated automatically from RightSoft if you're doing a heat load calculation. So whenever you're doing a heat load calculation, this would be 49 and 49 automatically populated. But you can also change it to 60 from the table. So in this case, we're going for the higher buffer, 60. So ventilation airflow rate required for the continuous system, it's 60. And then it says design for this system, ventilation airflow rate, 60. So the 2 points that I want to explain in this video is what is this runtime per cycle and what is this cycle time? And that is very important for intermittent ventilation, because for intermittent ventilation, we're talking about two important factors. Run time. There we go, run time, and that's going to be per cycle. See, let's put in here per cycle. Okay, and then we're going to be talking about the cycle time. What is the cycle time? See, cycle time. Okay, cycle time. All right, so equal and equal. So runtime per cycle and cycle time. And intermittent ventilation means on and off. So usually these fans are located in the bathroom or in the master bedroom or wherever it doesn't create so much disturbance. And that's going to be actually the whole house ventilation. Whole house ventilation. So in order to provide and to comply with ASHRAE 62.2, there are different methods. One method is the exhaust method. Method number 2 is the supply air or fresh air method. And number 3 is the balance method or ERB, HRB. In this case and in all my videos, we've been talking about the exhaust method. And this exhaust method works by utilizing exhaust fans. And pretty much this exhaust fan is going to vacuum all the air from the house, so that way your house is under negative pressure. When it's under negative pressure, under vacuum, that means that it's going to bring fresh air from outside through the cracks. But the problem with this is that also with fresh air through the cracks, it's going to bring also humidity. So sometimes there are humidity issues. But why are they using the exhaust fans? Because it's also more inexpensive. But a better option would be a fresh air method or supply method. So this is going to go away possibly like 1, 2, 3 years. They're going to go away. It's better to have your house as a positive pressure, which means air coming out from your house kind of thing, because the houses are getting tighter and tighter. But these videos are in order to understand how this works, so that way the contractors understand what these standards are, and the engineers know how this is installed and how they are all related. So this is pretty much the connection. All right. All right, let's get back to it. So in order to calculate the cycle time and run time per cycle, we need to understand this part. So the continuous ventilation is 60 CFM, all right? So we're gonna use this fan, which is, if I need 60 CFM, there are two fans. Let's put in here, as an example, Braun QTXE 80, and then Braun QTXE 110. Say that those are the manufacturers. Those are the exhaust fans. These are the fans. And the fan exhaust, the ones that are going to be located in the bathroom, exhaust. All right, and you can usually use another manufacturer like Panasonic. There are like Aprilia, and there are different manufacturers. But in this case, we're utilizing Braun. So for QTXE, and there are different exhaust fans. So for QTXE 80, that means 80 CFM. It's gonna subtract 80 CFM, or QTXE 110. So for 80, you need 60 CFM, and you have in here 80. So we're gonna go for the 110 to be safe. We can also go for the 80, but your fan is gonna be running more time. So let's put the 110. How do we calculate the cycle time? And how do we calculate the runtime per cycle? The calculation is not that complicated, and we're gonna put in here the following. Let's see this. All right. The QTXE 110 is gonna tell you that you need, this is going to provide 110 CFM. Okay. So you need 60 CFM. So how much time is gonna be running? In order to calculate how much time the fan is gonna be running, you're gonna put 60. You need 60 CFM. That's needed. That's needed. Who says that? ASHRAE 62.2. Wait a minute. Which year? 2010. Because 2013 and 16 will tell you more. You need more CFM. And also I'm going for the higher exhaust fan because sometimes the installation is not perfect. Most of the time it's not perfect. So this is under good condition. So we have more buffer and more CFM, that's better. So that's needed, and we're going to divide this by what is provided. This is the provided from the exhaust fan. Provided from the fan, exhaust fan. Okay? And then how much is going to give us that? That's going to be 60 divided by 110. That's going to be 0.45. And then in order to make it in a percent way, times 100. How much that's going to be equal to 55%. All right. So in other words, I don't want to make this complicated. We're going to put this 60 divided by 110, and that is times 100. That's going to give us 55%. And what is that called? We're going to put that in, say, green. That is going to be the operation time. Operation or operating time. So what does that mean? That means that the fan has to be running 45% of the time. So in this case, we're going to put the following. 55% of the time. So in an hour, how much that's going to be running? So let's make this formula a little bit better. I want to generalize everything, so that way everything is quicker and easier. 60 CFM, and I'm sorry for the redundancy, divided by 110 times 100, you make it as a percentage, times 60 minutes. So that way you're putting an hour. Okay, so I'm gonna make this as a formula like this, like that's the formula. There we go. Formula for who? For intermittent ventilation. Nice. There we go. Hopefully everyone sees that. Okay. So in order to calculate that, if you put 60 CFM divided by 110 times 100, because that's going to give us the percentage, how much percentage of operating time, and 60 minutes means like per hour. So we're assuming that the cycle time is every hour, 1 hour or 60 minutes. You depends how you want to call it, 60 minutes or an hour. Okay, so how much would that be? That means that if you replace all this data, that's going to give you the following. That's going to give you that you need 33 minutes. 33 minutes. All right, so that would be called the run time. Run time per cycle. Run time per cycle will be 33 minutes. All right, so the runtime per cycle is 33 minutes and the cycle time is 60 minutes. So the fan, this fan that is installed in the bathroom, and there is only one whole house ventilation, of course there is a fan in every bathroom, but that's a bathroom fan. But there is going to be a major master fan, which is called the whole house ventilation fan, that is going to be installed either on the second floor in one of the bathrooms, master bathroom, or any other bathroom that doesn't create so much disturbance. And that's going to be the one that will provide fresh air ventilation to comply with ASHRAE 62.2 2010. So in other words, what you would have to put in here in this form, which is for Energy Star, when they're asking you intermittent ventilation runtime per cycle, you would put in here runtime per cycle 33 minutes, and then the cycle time 60 minutes. Now Braun actually complies with intermittent ventilation in 3-hour segments. So in 3 hours, this is gonna get deeper and there's more calculation on that, but as a basic example, as to understand how this works, number one, how much does this house requires in order to comply for fresh air and in order to have a healthy house? They require 60 CFM based on the table of continuous ventilation. For the formula is 49, it's very exact, but 60 CFM is better because we give a buffer. It's safer, worst case scenario. But now we don't want this fan to be working 24/7 because that's gonna imply more energy consumption. So that's why they comply with intermittent ventilation, for which we chose this fan 110, which gives me a runtime per cycle of 33. But if you try with 80 CFM, that's gonna actually give you more run time, which is gonna be 45 minutes every hour. So it's running more. It's better to have a bigger fan in this case. And how do they do that? Because usually you have in the bathrooms a switch on and switch off. Like whenever you go to the bathroom, you switch it on or switch it off. Actually, they usually control this with this, which is called a controller. And this takes care of running the fan as the runtime per cycle and the cycle time. And there is also a way to make the programming for this, which is you tap it in here, you that 1, 2, 3 taps, but they usually take care of that. All right, so I hope you enjoyed this video. And also one more thing, so we're taking into account the bigger exhaust fan, because I was talking about the installation is not perfect. 99% of the time is not the perfect, because 110 CFM actually it depends on the static pressure. So depending on the static pressure, this is at, let's put in here, at 0.10 external static pressure. So what is the static pressure? A static pressure means the resistance. In other words, if you installed very well, you put your flex duct that is connected here. This is 6-inch flex duct. If you connect this very well with the flex duct to outside, see outside, this is the wall, and this is the wall, and it's connected outside very nicely like that, you're gonna have this 0.1 static pressure one at 110. However, usually it doesn't work like that way. Sometimes you have to make some bends like this, another bend like that, and sometimes this duct, flex duct, is not a straight flex duct. So whenever you don't have a straight duct, or is not completely straight, you create more friction, you create more resistance. When you have more resistance, your fan is not going to provide 110, it's going to provide less. For example, this fan, which is the QTXE 110, is going to provide at, let's put more resistance in here. So let's put more resistance at 0.25, because we're adding more resistance. Why are we adding more resistance? Because my duct is not straight, or maybe it's very long. So say that it's at 0.25 external static pressure, which means resistance. See, it's less static pressure, more static pressure. This CFM is going to be lower. It's not going to be 110. Actually, it's going to be 86 CFM, which is going to have to increase your runtime per cycle. So that's also a very important fact. The better your installation, the better you, the better efficiency on your fan. And maybe in the next videos we're going to be talking about the external static pressure and everything like that. Okay, so I hope you enjoyed. I hope you enjoyed this video, and if you do, subscribe and hit the like button. I'll see you in the next video. Thank you so much.